Let's look in detail at trigonometric functions and learn how to analyze them by looking at their amplitude, period, midline, and phase shift and building trigonometric graphs. We'll start with the midline. The midline is a horizontal axis that is the midpoint between the maximum and the minimum values on the trig function. For example, this is a sine function that's been shifted vertically, and so its midline is no longer along the x-axis. Its midline has been shifted up. It has a maximum of 3 and a minimum of 1, so we would find the midline by going 3 plus 1, which is 4, divided by 2. The midline is 2, which you can see visually, but analytically it's the max plus the min divided by 2. Going from the midline, we find the amplitude. The amplitude is the maximum change of the function, and it is an absolute value from the midline. Now, both of these functions here, the pink and the blue, do have midlines along the x-axis. So it's very easy to determine their amplitudes. The pink function is the standard sine function with an amplitude of 1. It goes plus or minus 1 from the midline. The blue function has an amplitude of 3, plus or minus 3 from midline. It's important to note amplitude is always positive. It is an absolute value because it is the distance from the midline. So putting it all together, how do we graph a function is in the form of a times the sine of bx, where a and b are integer numbers. A and b are numbers. Well, the amplitude is a. It is going to be the absolute value of that number that's in front of the sine or the cosine function. In this case, this is f of x equals 4 sine 2x. So a is equal to 4. So it is an amplitude of 4. It goes plus or minus 4 from the midline. We know the midline is 0 because there's no number after this that shows a vertical shift. The period, we know the sine and cosine unaltered have periods of 2 pi. However, putting a number in front of that x inside the input of the function changes the period from 2 pi to 2 pi divided by whatever that number is. If that number isn't there, or it's 1, then the period is just 2 pi. But in this case, that number b is 2. So the period of this function is going to be 2 pi divided by 2, which is just going to be equal to pi. So instead of making its full cycle in 2 pi, this function actually makes its full cycle from 0 to 1 to negative 1 to 0 in pi radians. So that's kind of putting it all together. Amplitude, midline, and period. Amplitude, the maximum amount it varies from the midline, is an absolute value. Midline is the middle point halfway between the min and the max, and the period is how long it takes to make a complete cycle. That's going to be, for sine and cosine, 2 pi divided by b. So let's put it all together. How do we graph a function in the form of a times the sine of bx? First, you got to determine the amplitude and the period. Amplitude is just the absolute value of that number in front. The period is 2 pi divided by that number b. Now, if there's a number after this, like say plus 3, that means there's a vertical shift, so the midline is going to be this number right here. But let's assume that's not there. Then you're going to find the x values for key points, intervals of p over 4. Now the reason we do that is because we can break the sine and the cosine functions up into those quadrantal angles at 0, pi over 2, pi, 3 pi over 2, and 2 pi. We can do the same thing for the cosine graph. Use those quadrantal values. And you remember, at the quadrantal values on the unit circle and on their graphs, it either has values of 0, 1, or negative 1. So it makes it easy to plot the graph. So once you found those x values, you find the y values at those points, and then you plot them on graph paper, and you connect them with a smooth curve. Now remember, the sine and cosine functions repeat themselves indefinitely, so you're going to extend the graph to the left or the right. Repeat. Well, now we're going to talk about phase shift. And phase shift is the amount a function is shifted to the left or the right. We get phase shift by changing this input to the sine. And we're going to add this little number called c, which is not the phase shift by itself, but together it will the phase shift. We're going to take that whole bx minus c term, put it in parentheses, and set it equal to 0, because just like we've done with other shifts, horizontal shifts, we're going to set the input equal to 0. So bx minus c equals 0, and solve for x. Well, if bx minus c equals 0, move the c to the other side by addition. You're going to get bx equals c, divide by b, so you get x equals c over b. And that tells you what the shift is. That value of x is the phase shift. If it's positive, it's a shift to the right. If this phase shift is negative, it's a shift to the left. Now notice that this is a source of a lot of confusion. This negative C, this negative sign in front of the C, means that if you're just looking here and you see a negative sign, that's actually going to be a shift to the right. And if you're looking here and see a positive sign, you see a shift to the left. But when you go and solve it, you get rid of the negative, and that's why this is really the best way to do it. It is C over B, and a positive number means a shift to the right, and a negative number is shift to the left. So let's add phase shift into the mix here. Now we can handle functions in the form of a times the sine of bx minus c, where they're a little bit more complicated, and that means we have some sort of a horizontal shift, which we call a phase shift with trigonometric functions. So as before, we're going to determine the amplitude and period. If there was a number d at the end, there would also be a vertical shift, and the phase shift, which is going to be c divided by b, making sure you account for that negative side. Just solve this, set it equal to 0, and you'll get the phase shift. Find the x values for the key points at the intervals, but instead of just p over 4, we're going to start by adding that phase shift in there. So if it's a shift to the right, we're going to move to the right and then add those intervals of p over 4. So the two big differences here that we're adding on here, we're accounting for a phase shift because we have this c term in there, and by doing so we've got to compute the phase shift and then add it to find where we start the graph. Otherwise the process is exactly the same. So we're just going to use different x values now because the function is not starting at 0 anymore, it's starting at some point to the left or right of 0. Let's put it all together now. This is a function that's got everything in it that we're covering. So first of all, we're going to turn the amplitude, midline, period, and phase shift of this graph. It has an amplitude of 2. That's the absolute value of the number that's in front here. So A is 2. So we know it's going to go up or down 2 from the midline. The midline, though, has been shifted up to 1. So the midline of this graph, instead of being on the x-axis, is at 1. But it's going to go up or down 2 from that. So I'm going to put lines here. Up 2 from this midline, it goes down 2 from the midline. It's going to wind up having a maximum of 3 and a minimum of -1. Period, there's the b. We know the sine function normally is a period of 2 pi, but we've got to modify that because the b changes the period. So it's going to be 2 pi divided by 2. Period is going to be pi radians. That's very important. Instead of 2 pi, it's going to be pi. It's twice as busy as the regular sine function. Now we need to find the phase shift. Now the phase shift is what we're going to get by taking this whole section here and setting it equal to 0. 2x minus pi over 2 equals 0, and solve that for x. Alternatively, you can say it's c over b, and c would be pi over 2, and b is 2, so you're going to get pi over 4. When you solve this, you're also going to get pi over 4. The phase shift is a positive pi over 4. It is going to be moving to the right pi over 4. So instead of starting at 0, this thing starts at pi over 4. Step 2, so that's where we're going to actually start our graph, our value of 1. So let's find the x values for key points at the intervals of the phase shift plus the period divided by 4. In other words, we're going to get those quadrantal points. Well, we know the phase shift is pi over 4, and we know p is pi. So what we're going to do, the intervals are going to be, I'm going to make a little table down here for my x values. I know I'm starting at pi over 4. Well, what's my interval? I'll call that I. It's going to be the phase shift, which is pi over 4, plus the period of pi divided by 4. So the interval actually is pi over 2. So each point I'm going to add pi over 2 to it. So if I add pi over 2 to pi over 4, I get a common denominator of 4. That's going to give me 3 pi over 4. So my next point's got to be at 3 pi over 4. We're going to go another pi over 2, going to continue to add another interval to this. If I add pi over 2 to this, common denominator, that becomes 5 pi over 4. Okay, and you can even kind of see the pattern, so you know the next one's 7 pi over 4. And I just need one more point to finish it, and that should be 2 pi plus pi over 4. Indeed it is, it's 9 pi over 4. Okay, so now it's just a matter of finding the values at each of these points. Now normally the sine function goes 0, 1, 0, -1, 0. Part of that wave that the sine function makes, we have to modify these values to account for a function. We're multiplying it by 2 and we're adding 1. And you can also get that by just putting the x values in here. You'll get the same values, but this is a little bit of a shortcut if you remember the pattern. Well, 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. So at 3 pi over 4, the value is actually 3. 5 pi over 4, the value is 0, and so it goes back down to, in this case, 1, because 2 times 0 is 0, plus 1 is 1. Negative 1, if we put in a negative 1 in here, we get negative 2 plus 1, which is negative 1. That's where it reaches its minimum. And then put in a 0 again for sign. Here you get 2 times 0 plus 1 back to 1. Okay, so this is actually what the function does. Pi over 4, 1, 3 pi over 4, 3, 5 pi over 4, 1, and 7 pi over 4, negative 1, and 9 pi over 4 goes back to its midline. If we plot these points, pi over 4, 1, 3 pi over 4 goes up to 3, 5 pi over 4 goes back down to its midline at 1, 7 pi over 4 it goes down to its minimum of negative 1, and at 9 pi over 4 it completes its cycle and goes back to 1. Let's connect those dots. Smooth curve. We'll do the best I can with this mouse. Okay, and then extend it to the left or the right because it does repeat itself. So that is a graph that has a different amplitude, period, phase shift, and midline from the sine function, its parent function. We've taken it and broken it down and graphed it.